production of electricity can be from different devices. First one is from solar energy. After that, we'll go on to the production of electricity from wind energy. After wind energy, we'll go on to from hydro energy. And the last one we are going to do from nuclear power plant. The last one we are going to do production of energy from electrical energy from nuclear energy. Now, here we have a solar cell. Now, what is a solar cell? A solar cell actually what a solar cell does, a solar cell converts solar energy directly to electricity. Converts solar energy directly to electricity. Now you can see the solar cell over here. What does this solar cell do? It converts solar energy directly to electricity. Solar cell is usually made up of semiconductors. Now, to increase the efficiency, a number of solar cells are joined together to form a solar panel. It forms a solar panel. Now, what does this solar panel do? It is a combination of solar cells. So, you can see sunlight falling on it. You can see sunlight falling on it. Now, what does this do? It creates electricity. This goes to a battery. And once it goes to a battery, you can see that it can be used in various ways here, like it's used in electric motor to take up water from pump. You can use it in other cases also. It can be used for street lighting, radio, television, whatever, in many other things also. So here what happens? This is a way where electricity is produced from solar energy. Now, what are the advantages of this solar energy? For the use of electricity, number one, they do not require any maintenance. Number one, they do not require any maintenance. Number 2, they last over a long period of time. Since sun's energy, you have a lot of sun's energy, so they last over a long period of time. Next, what you can say? You can say running cost is almost zero. Running cost is very low. Their running cost is very low. You can also say they are most suitable for remote places where power lines cannot be laid, or you can say they cause very little pollution. They do not cause any pollution in the environment. They do not cause any pollution in the environment. Now, but what are the disadvantages? What are the disadvantages? Initial cost of solar panel is very high, children. Initial cost is very high. Installing it will cost you a lot. Next, the efficiency of conversion of solar energy to electricity is low. Efficiency is usually low. The solar panel produces DC electricity, which cannot be directly used for many household purposes. It produces DC. Direct current, and this cannot be used for many household purposes. Now, from the beginning, what we can say, this is one method of producing electricity. This is number one method which we are discussing. Solar energy to electricity, that is done by solar cell. A combination of solar cell form a solar panel. It converts solar energy directly to electricity. And from here, you can use the current in various ways. Here, the current is used in electric motor to lift a pump. The advantages, what are the advantages? They do not require any maintenance. They can last over a long period of time. Running cost is low. but installing cost is high. They do not cause any pollution. Pollution is very little. The disadvantage is initial cost is very, very high. Efficiency is usually low, and it produces DC, which cannot be used for many household purposes. Now, the next form of energy is wind energy, from where we can get electricity. So the second form is wind energy. Now what happens, children, in a magnetic field, say you have a magnetic field, this is a north pole and a south pole. In a magnetic field, if you have a coil, this is a coil, and if this coil is rotated, in a magnetic field, then what happens? You get current. Current is generated. So, in a magnetic field, when a coil is rotated, current is generated. Now, in wind energy, what happens? Can you see the magnets? This is the magnet, North Pole and the South Pole. And there you have the armature, which is connected to terminals T1 and T2. Now, if within a magnet a coil is rotated, current is generated, then in this, between the magnetic field, you have the coil connected to the terminals T1 and T2. Now, who is rotating? The wind energy will rotate this. This is connected with a rod, with a shaft to the blades. Wind energy will rotate. And as a result, what will happen? Within the magnetic field, the armature coil will rotate. And when a coil rotates in a magnetic field, you get current. Here an alternating EMF is produced between the terminals T1 and T2. AC is produced. AC is produced. AC is alternating current. AC is produced in the terminals T1 and T2. Now, the electric power generated by a single windmill generator is small. So, to generate a sufficient amount of electric power, a large number of such wind generators are arranged over a big area called a wind farm. And the electric power generated by each generator is combined together for the supply of the consumers. Now, what are the advantages of using wind energy? What are the advantages of using wind energy? Now, it does not cause any type of pollution. It does not cause any type of pollution. Number 2, it is an everlasting source. It is an everlasting because it lasts for long. It is a renewable. Source. What are the disadvantages? What are the disadvantages of having electricity from wind energy? Now the limitations are the wind farms can be established only at places near the coastal areas. So wind farm can be established wind farms can be established only at places near coastal areas where you have wind, and the wind speed should not be less than 15 km per hour. The wind speed should not be less than 15 km per hour. Secondly, a large area of land is needed. A large area of land is needed for the establishment of the wind farm. Number 3, the establishment of a wind farm is expensive. It is very expensive. So, from the beginning, if we go to the wind energy, which was point number 2, whenever you have a coil rotating in a magnetic field, you have current being generated. Now, who is rotating the coil here? Here you can see the North Pole and the South Pole. You can see the magnet, and within the magnet you can see the armature coil. This is the armature coil. So the armature coil who is rotating the wind, and you get a current. Now what are the advantages? It does not cause any type of pollution. It is an everlasting renewable source. You can use it again and again. What are the disadvantages? Wind farm can be established only at places near the coastal areas where the speed of the wind should not be less than 15 km per hour. So very high speed wind you need. Now, large areas of land is needed to create a wind farm, and this is very expensive. The next type of production of electricity is from hydroelectric plant. Now, just now we saw that if in a magnetic field you have a coil, and if you can rotate the coil in a magnetic field, what do you get? Current is generated. Current is generated. By any means, if you can rotate the coil in a magnetic field, you get a current. Now, in hydroelectric power plant, what happens? Water is taken to a top. Now, this water has gravitational potential energy. It has gravitational potential energy. Now, when this water falls on a turbine, you can see the water turbine. Now, this moves the turbine. Now the turbine is connected to a shaft, and here is a coil with this is the magnet, North Pole and South Pole, and the coil is connected to a shaft. Now the shaft is connected to a turbine. Now who is rotating the turbine? The water is falling and rotating the turbine. Now as the turbine rotates, what happens? The coil which is connected to the terminals T1 and T2, coils which is connected to terminals T1 and T2 rotates. And when a coil rotates in a magnetic field, what do we have? You have current generated. Here you have current generated. Now, what are the advantages? What are the advantages of this hydroelectric plant? Now, in hydroelectric power plant, it does not produce any environmental pollution. It does not produce any environmental pollution. Number 2, it is a renewable source of energy. And number 3, the dams constructed over rivers help us in irrigation. It helps us in irrigation and control of floods. Now, what are the disadvantages? What are the disadvantages? Number 1, flowing water is not available everywhere. The flowing water is not available everywhere. Number 2, due to construction of dams, plants and animals are getting killed. Due to the construction of dams, plant and animal life is destroyed. Number 3, you can say the ecological balance. The ecological balance in the downstream areas of rivers get disturbed. So what can you say for hydroelectric power plant? Now we know in hydroelectric power plant, water from top has a gravitational potential energy. It has a gravitational potential energy. It moves a turbine. The turbine moves a coil in a magnetic field. And whenever a coil is moved in a magnetic field, you get a current. Now, the advantages of this hydroelectric power plant is it does not produce any environmental pollution. It is definitely a renewable source of energy. Now, it helps in irrigation and flood control. The disadvantage is it is not available everywhere. Everywhere you won't get this water flowing. Now, when you build dams, plants and animal life is being destroyed, and ecological balance in the downstreams get disturbed. So we go to the last type, production of electricity from nuclear energy. Now, we go to production of electricity from nuclear energy. Nuclear energy. Now, in nuclear energy, what happens? A slow neutron a slow neutron. It is a slow neutron. Now, this goes and hits uranium 235. Now, uranium 235 absorbs this and immediately it turns to uranium 236. Now, this uranium 236 is very unstable. It is very unstable. What happens? It immediately breaks up into barium, krypton, and 3 more neutrons. Now, if all these masses were added up, mass of neutron, barium, neutron, krypton, if all the masses are added up, the masses come out to be 235.8 atomic mass unit. But it is coming from which mass? It is coming from 236. And if you add all these masses, you get 235.8. Now, where does this 236 minus 235.8, that is 0.2 atomic mass unit, where does this mass vanish? Children, this mass goes on to an energy from Einstein, which is called E is equal to mass into c square, where mass is this 0.2. This mass is 0.2 and the energy goes to E equal to mc square. Now, this is a huge amount of energy. Now, in one reaction, a huge amount of energy is created. Now, what happens? This neutron again goes and hits. There are 3 neutrons. They go and hit 3 more uranium 235. Because it is a slab of uranium 235. And it turns to uranium 236. It turns to uranium 236, which is again very unstable. And from there, what do we have? From there, you have 3 neutrons coming out, along with barium and krypton. Along with barium and krypton, we have 3 more neutrons coming out from each uranium. So here again you have 3 neutrons coming out. Here again you have 3 neutrons coming out. Now one neutron here gives out 3 neutrons. Now 3 neutrons will go and hit uranium-235, 3 uranium-235. And they will give out 9 neutrons. Again this 9 neutrons will give out 27 neutrons. And each neutron will start a reaction. For every reaction, the energy E equal to mc square is quite large. So what happens here? First, one neutron gives to 3 neutrons. Then 3 gives out 9. Each 9 gives out 27 neutrons. Now, each reaction, each neutron will cause one reaction. So the reactions will start in a rapid way, and this is called uncontrolled fission. Now this is what happened in Hiroshima, Nagasaki. Einstein did not want to destroy mankind. Einstein thought that very soon Earth is going to become a cold planet. Somehow we have to create energy. So he found out this, that when a slow neutron will hit uranium-235, it will turn to uranium-236, which is unstable, which will break up in a less mass, and that mass will be converted to energy. This is what Einstein wanted to do. But his formula was leaked out, and we have seen Hiroshima, Nagasaki. Now what did Einstein want to do? Einstein said that one neutron will give 3 neutrons with the release of energy. Now, if we can use cadmium rods, now cadmium rods are neutron absorbing materials. Now he said, let us use cadmium rods. Now say this is a cadmium rod. This is cadmium. Now what does a cadmium do? Cadmium rod absorbs neutron. So he said, let 3 neutrons come out, but let us use cadmium so that cadmium will absorb 2 neutrons and allow only 1 neutron to go. So what will happen? My reaction will be controlled. Again, when 3 neutrons will come out, again we can use cadmium rods over here, which will absorb. Again, let us use cadmium rods to absorb the neutrons. So let only 1 neutron go. So uncontrolled fission will become controlled fission. Uncontrolled fission will become controlled fission, and the energy can be used to produce electricity, and that is known as a nuclear reactor. Einstein wanted to form a nuclear reactor. He wanted to find out a nuclear reactor where this energy can be used to produce electricity. Now let us see What is a nuclear reactor in a power plant? Now, in a nuclear reactor, what happens? If you look here, this is a nuclear power plant. See, you can see the uranium rods. Now, what is this graphite block and heavy water does? Now, graphite block and heavy water, what they do? They slow down neutrons. They slow neutrons. Why do you need slowing down neutrons? Because to start the reaction, here you need slow neutrons. You need slow neutrons to start the reaction. So here, the graphite and heavy water, they slow down the neutrons. Now, these are the uranium rods. You can see the uranium rods. These are the uranium rods. These are the uranium rods. Okay. Graphite and heavy water will slow down the neutrons. Uranium rods, uranium-235 neutrons will go and hit. Now you can see the cadmium rods. See the cadmium rods. What does the cadmium rod do? These are the cadmium rods. These are the cadmium rods. Now, what does the cadmium rod do? The cadmium rod, they absorb the neutrons and change uncontrolled fission to controlled. So, the energy now liberated is within limit. Now, what does this do? The heat generated, what happens? Here you see cold gas here, gas comes in, cold gas comes in, gets heated and comes out from here. It gets heated over here and comes out from here. It comes in from here, comes out from there as hot. It gets heated due to the heat produced. The hot gas comes out. And what does the hot gas do? Here, cold water is coming. The hot gas comes in, heats the cold water, and what do you have? Steam coming out. Now, what does the steam do? It turns the turbine. What does the steam do? It turns the turbine. Now, what does the turbine do? Can you see the magnet here? The North Pole and the South Pole. Inside, what do you have? The coil with terminals T1 and T2. The turbine rotates the coil in a magnetic field. And what do you have? Current generated. So from here you see graphite and heavy water. It will slow down the neutrons. The neutrons will go and hit the uranium rods. Now these uranium rods, 3 neutrons emitted, 2 will be absorbed by the cadmium rods. The cadmium rods will absorb. From here, cold gas will come. Cold gas will come. Cold gas will turn out as hot gas. Now, when hot gas comes out here, cold water comes in. As cold water comes in, it gets heated by the hot gas. Steam comes out. Now steam rotates the turbine. With the turbine, with a shaft is attached the coil which rotates in a magnetic field, and whenever a coil rotates in a magnetic field, you have current generated. This is how nuclear energy is used in the power plant. Now, what are the advantages of using nuclear energy? Now here, number one, a very small amount of nuclear fuel can produce tremendous amount of energy. A small amount of nuclear fuel can produce tremendous amount of energy. Point number 2. Once the nuclear fuel is loaded, it continues to release energy over a long period of time. It continues to release energy over a long period of time. It continues to release energy over a long period of time. Now, what are the disadvantages? What are the limitations? Now, it is not a clean source of energy because it is very harmful. The nuclear radiations are highly energetic and highly penetrating. They cause ionization and are very harmful. So, number 1, not a clean source. It is not at all a clean source of energy. Very, very harmful. Because the nuclear radiations are highly energetic and penetrating, they cause ionization to the human body and high standard of protection is needed. Number 2, the waste obtained causes high degree of environmental pollution. Number 2, the waste obtained from the nuclear power plant cause high degree of environmental pollution. So, nuclear power plant, although they give us very high energy over a long period of time, it is not a very clean source of energy and cause environmental pollution.